Good morning, everyone. My name is Mihai. I am a partner in the firm's Miami office, and today I will be talking to you about 3D printing, which is also known as additive manufacturing. And because I'm on a very tight 15-minute, and I see you looking, timetable here, this is going to be a high-level overview of what 3D printing is, what some of the legal issues are that exist in the 3D printing world, what some of the uses are for 3D printing. But if you want to go more in-depth, do please feel free to talk to me after the presentation, and I'll be glad to tell you everything I know about 3D printing. So with that said, what is 3D printing? The concept is actually pretty simple. 3D printing is taking an idea, inputting it into a computer, creating what's known as a CAD file. That stands for Computer Assisted Design. So you have a CAD file, and then you translate that CAD file using a printer into a actual three-dimensional object that you can hold in your hands. Now, the American Society for Testing and Materials has come up with 7 categories that describe the various procedures for actually printing out a three-dimensional object. And you see them right there. They all have very fancy technical names, but really they all mean one thing. 3D printing is the process of creating a three-dimensional object one layer at a time. And you can have hundreds, thousands of layers. So the printer just lays down whatever your medium is, whether it be a polymer, a metal, even cellular material. It lays it down one layer at a time until you have the object. So those are the 7 traditional categories. Now, just very recently, I think it was last month, Harvard's Weiss Institute came up with an 8th category, an 8th process for creating 3D products. And this is so new, it doesn't even have a name yet. But what it is a process that moves away from the layering procedure that I described. And what they're doing is they have this device with a nozzle that shoots out silver nanoparticles. And those nanoparticles are hit by a laser beam immediately after they come out from that nozzle, and they're hardened. And you actually are able to almost draw this, whatever it is, it looks like a coil here, but you will be able to draw the product in mid-air using this process, which again is so new, it doesn't have a name yet, but I wanted to bring it to your attention because I think it's really amazing. So with that said, where do we see 3D printing today? Well, we see it in the recreational context. There are websites out there that you can go to, and you can either buy a CAD file, send it to them, and they can print whatever you want. So if you want a pink Yoda head, you can have a pink Yoda head on demand. You can have iPhone covers, pretty much whatever you want. Just by show of hands, how many of you have actually used one of these services? Nobody. Well, you can do it if you want, folks. So definitely give it a try. I think Amazon is getting into it. It's really a cool thing to do. And folks out there, is anybody here a member of the Cat Addicts Facebook page? Now, well, the Cat Addicts Facebook page envision a day where you will be able to print out your own furry friend like the one in that photograph. Now, you all may think this is funny, but you know what? One day we could actually be able to do this because scientists are currently working on something that's called bioprinting, which is creating actual biological structures. Today they're working with cells, and they're printing cells in layers, trying to create various structures. But the idea is that eventually you'll be able to print out fully functioning organs. And in this, on the right-hand side there, you'll see a conceptual drawing of a printer printing out a heart. So, that's something that we're looking at. 3D printing in the medical space is also being used in prosthetics. It's also being used in various medical devices. The last I checked, there were about 85 medical devices that were using 3D printed technology that have been cleared by the FDA. It's also being used in medications. Now, they're actually 3D printing tablets that have a unique structure that when you take them, they dissolve a lot faster as a result of that unique structure that is only possible through 3D printing. We also see 3D printing in the industrial space. Currently, companies are using it to create components. They're not really using it to create fully assembled working mechanisms. But folks are working on actually creating a 3D printer that will allow you to create fully functioning devices. Like our friend Keanu here says, wouldn't it be cool if we can have a 3D printer and then have it print out more 3D printers? And that's what we're getting at, although that is going to make life a lot more complicated for our IP friends, I think, when you're able to do that. But that's just one of the possibilities that exists with 3D printing, and it's some place where I think the industry is heading. 3D printing, we're also seeing it in construction. Here, this is an office building that was just finished up a couple of months ago in Dubai. As I understand it, they used a giant 3D printer to create the various components, and they had one guy who supervised the printer, and then there were 7 other folks who actually assembled this building, and it took them 14 days. Think about it. An office building built by 8 people in 14 days. That's just remarkable. We also see 3D printing in the fashion world. Some intrepid designers are creating, I think it's a bathing suit, I'm not sure. I've asked my co-speakers here, they're not sure either. But if you are looking for some type of garment that resembles brain tissue, intestines, I don't know what that is, then 3D printing has you covered. And it's something that you could purchase, I imagine. And finally, we also see 3D printing used in food preparation. Again, because of 3D printing's unique ability to create these very sophisticated, complex structures. Here, I don't know if you can really see it, but those little pastries she's eating have this very organic structure. That's something that would have been very difficult, if not impossible, to do with traditional baking techniques before. So that's where we also see 3D printing coming up, and it's becoming more and more prevalent. These are some of the benefits, and I don't have a lot of time, so I'm going to kind of fly through these. Basically, 3D printing allows you to bring your ideas to life, whereas before it would take you days or weeks to think up an idea and then hold it in your hands. Now you can do it in a matter of hours because of just how quickly 3D printing allows you to materialize those thoughts. So I'll skip over these. So let's now turn to, I guess, the CLE component of my presentation, which deals with some of the legalities. First of all, I think it's important to acknowledge that we're still living in the Wild West when it comes to 3D printing. The last I could find, looking at product liability, I was only able to find one case involving the maker of Invisalign, so that the other cases with 3D printing, they all involve IP, but there aren't any other product liability cases out there. There aren't really any regulations. The FDA, I believe it was last month, issued a draft guidance for medical devices, but that is the only regulation that I was able to identify. And like I said, it's the Wild West out there. But I'm sure as 3D printing becomes used more and more and more, we're going to start seeing lawsuits coming up in more high-risk products like airplanes, automobiles, those sorts of things. And when a lawsuit actually begins, there are a lot of parties that can be brought into the mix. And here I list 7 of them. And these are going to be important when I talk about potential defenses, because if you're in a jurisdiction that allows comparative fault, these are all of the other potential parties that you can point the finger to if you're a manufacturer who uses 3D printing. So the first 3 of those talk about the creation of the CAD file. So a CAD file can be created just directly on a computer, or you can actually scan an original source object into the computer, create that CAD file, and then modify it as you see fit. So if you get hit with a lawsuit, you're a manufacturer, you can point the finger at the creator of that original product, its designer, its manufacturer, say there's something wrong with them. You can also point the finger at the maker of the scanner, say that the product, the original item was not properly scanned in because of something wrong with the scanner. You can point the finger at the scanning party. Then you can also, as you can see, point the finger at the CAD file designer itself if you're the manufacturer. The 3D printer manufacturer, they're probably going to get thrown in there too, because they will likely have deep pockets. So that's another party that could be brought into the mix. If there are any material issues, you can look at the bulk material supplier. And obviously the manufacturer using the 3D printer, that's another party that could be brought into the mix. So in terms of potential theories of liability, I think you have to look at manufacturers as belonging in one of the three classes that I have up there. You have manufacturers that purely manufacture, that don't actually do anything to the CAD file. And then you have those manufacturers that license the CAD file, slightly modify it in order to meet some type of customer demand, and then manufacture. And then you have those manufacturers that take it all from ground level. They design the product and they manufacture it. So if you're just a manufacturer that fits into category A, that doesn't do anything to the design of the product, then you're looking at traditional product liability types of theories that may be used against you, like manufacturing defect, failure to warn, both in strict liability and negligence. Obviously, if you fall into categories 2 and 3, then you're also looking at potential claims dealing with strict liability and negligent design defect. So that's kind of the framework that I've set up so I can think about this in terms of determining what potential theories a plaintiff may try to use against a manufacturer. So in terms of available defenses, I think, again, we have to look at which of those three classes the manufacturer falls into. If you're just a manufacturer who doesn't do anything to the design, then you will obviously have those traditional defenses like misuse or abuse, intervening superseding cause, and then if you're lucky enough to be in a comparative fault state, you can also point the finger at all the other parties that I talked about earlier. If you fall into categories 2 and 3, which is somebody that modifies the CAD file or actually creates the CAD file, then you would also have access to those defenses that are reserved for entities that also design a product, like, for instance, the government rules defense. So I'd like to conclude by giving you just some quick practical suggestions for, if not eliminating, lessening your exposure and liability if you are a manufacturer that uses 3D printing. The first one, and I think the most important and most effective one, is have solid defense and indemnity agreements. I can't overstate the importance of having these types of agreements with the CAD file designer, even the bulk material supplier, if it makes sense given the arrangement that you have, because these types of agreements can just cut off your expenses from the get-go. The second you get that complaint, you send it over to whoever you have the defense and indemnity agreement with, along with a letter saying, defend and indemnify me. And if they keep up their end of the bargain, then you're not spending any more money, hopefully. So that's the first one. The second suggestion I would have is establish quality control mechanisms and protocols that take into account the specific failure modes associated with your product and this type of a manufacturing process, which is a fancy way of saying basically if you know that your product is prone to fail in a certain specific way as a result of using 3D printing, make sure you have very good and clear quality control mechanisms in place to watch out for that type of defect. That's all that means. If you're one of those manufacturers that just slightly modifies the CAD file and then manufactures the product, I think it's also important to have comprehensive design history files in place. And what that will do is, if you get hit with a lawsuit, you can say, you know what, even though I modified this product's design, the design feature that led to the purported failure had nothing to do with my modification. So that's the logic behind that. If you are a manufacturer that produces items like, say, screws that are not easily distinguishable from your competitors' products, one thing that you could consider doing is putting some type of a marker on your product that will identify it as your product. So if a screw fails and a plaintiff sues 50 screw makers, you can say, that wasn't my product because all of my products have this mark on them. But you got to be careful because that can cut both ways. Depending on your market share, you may want that ambiguity to exist, and you may not want to, if you make 99% of screws, you don't want to have your name on all of your screws because it will make the case against you that much easier. And finally, proactively engage with your insurers to take into account the very unique risks that are inherent in the 3D printing process, and that's something you should get with coverage counsel and with your insurer and talk about. Make sure you're all on the same page, so if a lawsuit happens, there are no disagreements about who's responsible for what and what should take place. So that's all the time I have today. Thank you for your attention. If you want more information about 3D printing, I'm also very into robotics, particularly in the clinical space. I have a blog you can all go to. You can follow me on Twitter, email me, or just let's talk after today's presentation.